Okay, if we take a look at the UML diagram about inheritance, you'll see here we have graded activity, and down here we have final exam. Notice we have this line going up. We see whenever we see this triangle, or I should say arrowhead, and it's pointing to an upper class, that says that final exam is a graded activity. So there's the is a inheritance factor. So final exam is a graded activity. Now let's talk about superclasses constructors. If we go to, let's see, the constructor demo. So here I'm going to look at constructor demo, and here I have public class constructor demo 1, and there I have a public static void main, and it's blah, 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 blah. Well, what we're going to do is we're going to look at a subclass. So if I look at subclass 1, I can see that subclass 1 has a constructor. That's all that has. And that constructor says this is a subclass constructor. But notice that subclass 1 extends superclass 1. So subclass 1 is a superclass 1. If we take a look at superclass 1, all it is a constructor. It says this is a superclass constructor. Now, one thing I forgot to mention, kind of going back to the book, in that when we inherit from another class, we inherit everything but the constructor. We never ever get the constructor because that constructor is specific to that class. But whenever we do that inheritance, it will execute whatever is in that constructor. So the constructor will execute. So it's kind of like being instantiated. In a sense, we are. When we instantiate a subclass, we're also instantiating that superclass. So that superclass executes, then the lower class or subclass executes. Another thing I want to get another thing across here is the terminology. This is a superclass. This is a subclass. Another name is this is the base class, and this is what is called the derived class. So if you hear base class, it's the same as a superclass. If you hear derived class, it's the same thing as a subclass. Okay, so kind of getting back to this program. So if we run it, so if I were to run the constructor demo, we're going to see that down here in the console, we'll see that this is a superclass constructor, this is a subclass constructor. So again, when we instantiated this object as subclass 1, it does instantiate that superclass and that subclass, so the constructor will run up there in the superclass, and then the constructor will run down in the subclass as well. So be aware of that. But again, we do not inherit the constructor. The constructor stays with the superclass. Okay, so realize inheritance does not work in reverse, meaning like the graded activity or the superclass 1 over here. The superclass 1, if I were to create an object from just this class, well, let's do that. So if I go to demo 1, if I call this superclass, and now if I run this, we'll notice it'll just say this is a superclass constructor. Why? Well, superclasses are classes themselves, and you notice there's no way we can see this related any way, shape, or form to the subclass. So there's no way for the superclass to know that there's a subclass involved. So it does not work in reverse. It only works subclass up, because a subclass knows it's a subclass of a superclass, and so the superclass gets executed in a sense as well. So if we take a look at the next demo, which is the constructor demo 2, we notice that we have subclass 2 object, so same exact routine. And if I take a look at the subclass 2, we can see that it is it extends superclass 2. And we can see that here we have super 10, and then system out print line, this is the subclass constructor. What is this up here? We've got super and 10. Well, probably the superclass has a constructor and it's expecting an integer data type. So if we take a look at the superclass, sure enough, there's superclass 2. It says this is a superclass no-arg constructor. And then down here I've got superclass int. The following argument was passed to the superclass constructor. So it's kind of a way for us to call a superclass constructor from the subclass. We just say super. I don't have to call it superclass 2. I don't have to call it anything. In fact, it could have a name of Titanic. All I have to do is use the word super, and it knows that since I'm extended from this superclass, it knows to go up there to get that information. So since I'm passing, so if I have an int signature, I'm expecting this class to execute. So if we run this, nope, wrong one. There it is. So if I were to run this, it says the following argument was passed to the superclass constructor 10. This is a subclass constructor. So again, here's subclass 2. We pass that 10, and this is a subclass constructor. We look at superclass 2, and since we passed in this, it says the following argument was passed to the superclass constructor and the number 10. So, very, very powerful stuff here. Again, constructors aren't inherited, but the constructor will be executed. So, let's take a break there for a sec. Okay, so let's take a look at the cube demo. So we take a look at the cube demo, and there we have, it's a void main. So it looks like we have 3 local variables, length, width, and height, and then we basically are setting up a scanner keyboard. Enter the following dimensions of a cube: length, width, and height. And length is .keyboard. So basically we have those 3 variables set. Then I say cube, my cube is equal to a new cube, length, width, and height. Okay, so let's take a look at cube. So if I look at cube, says it's a class that extends rectangle. So here I have a public cube. So here's my constructor. I'm expecting a double, 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 and which is length, width, height, and I say super length, width. So I'm pulling in the length and width from the super, and I say height equals h. So in this case, I'm passing length and width to my super, and what's that going to do? Well, let's take a look at rectangle. So rectangle has two instance variables of length and width, and then we have rectangle length and width being passed in. I also have a, so it just sets the length and the width, okay? And then the public void set length and set width and get width. Okay, so now we go back to cube. So look at that. I've set the length and width of the rectangle class, and I've set the height of my cube class. And then I've got get height, get surface, which is get area times 6. What's get area? Well, get area is probably in the rectangle class. And sure enough, there's get area, which is length times width. Okay. Now realize the length and the width are private variables for the rectangle class. We can't get to those fields. We can't touch the fields, but we can get to the getters and setters. And since those fields are set within the setters and getters, they basically are now available to us via those methods. So I have the get area. I come back over here, and so I get the area times height. So I get the area, which is length times width. I multiply it times height. And so there's the area times 6. So that's the surface area. And the reason why we do that is there are 6 surfaces to a cube. So the total area of a cube is length times width times height times 6. And that will basically get us the total area. Okay, so pretty cool stuff there. So get area, length and width, all that basically is taken care of by our superclass. We don't have to deal with it down here in our lower class. So if I go to the cube demo and I go ahead and run this, it's going to ask for a length, we'll say 10, width we'll say 5, and height we'll say 6. And there we have a length. See, base area is 50, the surface area is 300, the volume is 300. So pretty cool stuff. So the great thing there is I have a rectangle class, and a cube's kind of a rectangle, except it's got one more dimension to it. So we can still use a rectangle class for the surface, and then we can actually add the height class, and then basically take the area and add to that as well. So kind of a great thing. So very, very powerful, this whole inheritance stuff basically going on. Realize that when a superclass has a no default or no arg constructor, that again, that particular information will not get executed. Okay. So if it has a constructor and it needs to utilize those different fields, we can actually use super dot get and get those particular fields if we need to get access to them. So to kind of wrap up the section of constructors, if we look on page 639, it says a summary of constructor issues in inheritance. Okay, so basically it looks like we have 5 different bullet items we really need to pay close attention to. Number 1, the superclass constructor always executes before the subclass constructor. Number 2, you can write a super statement that calls a superclass constructor. So you can write a super and then basically in parentheses type in whatever the signature of that constructor. But you can only do that in the subclass constructor. You cannot do it anywhere else. So you can only call a super constructor from a subclass constructor. If a super statement that calls a superclass constructor appears in a subclass constructor, it must be the very first statement. So if you can't basically do some instantiation, some other instance variables, and then call the super constructor, you have to do that first within the subclass constructor. If a subclass constructor does not explicitly call a superclass constructor, Java will automatically call the super, in parentheses, no arg constructor, just before the code in the subclass constructor executes. So if you don't call it, Java will call it for you. If a superclass does not have a default constructor or it has no arg constructor, then a class that inherits from it must call one of the constructors that the superclass does not have. So basically it should call its own superclass. Okay, so just a few things that we need to basically pay very, very close attention to when we're using inheritance, and we're basically utilizing the constructors as well. Okay, so we'll go ahead and end there, and we will pick it back up on page 640 when we get into section 10.3, overriding superclass methods.